Hello there, I'm Borna, your organic chemistry tutor, and today I'm back with another tutorial. We're going to discuss the mechanism of a sample Robinson annulation in this problem. Let's get to the board. Okay, so we were asked to come up with a mechanism for this Robinson annulation. The first thing that I want to do is that I want to locate the starting materials within the product. It appears to me that this 5-membered ring with its methyl has ended up here in the product, and this alpha-beta unsaturated alkene has ended up being here. Okay, well that seems to be reasonable, and that means that the bonds that have been made throughout the course of the synthesis, or this reaction, have been this bond and this bond. Now let's think about the mechanism of this reaction. In a Robinson annulation, there's going to be two processes that take place in sequence. There's going to be a Michael addition, and then there's going to be an aldol condensation. So Michael addition goes first, that's the key. The Michael addition, it appears, is going to be between the enolate of this diketone that we have right here. It has a pretty stable enolate it can form after you remove this hydrogen within the two or between the two carbonyls, and then that can attack our alpha-beta unsaturated carbon or carbonyl compound in a conjugated manner. So let's see. We have an alpha-beta unsaturated carbonyl right here, so it can attack the beta carbon, lead to an enolate, and that is going to look like this. So we have our diketone, and then that is going to get connected to our alpha-beta unsaturated carbonyl compound like this. And then once this abstracts a hydrogen from water, our Michael addition is done. Okay, let me draw that a little more neatly. So we have that. We have this methyl. We have this ketone right here. We have... Alright, so this is the product of the Michael addition. Once this happens, there is going to be an aldol condensation. And the aldol condensation is going to take place between the alpha position of the newly added alpha-beta unsaturated carbonyl compound and the ketone of the original Michael donor. So the first thing is that there's going to be a hydrogen removal from that position. So we're going to have that. That is going to give us an enolate that is going to be very reactive. An enolate that is going to be very reactive towards our ketone. So next thing that is going to happen is that it's going to attack our ketone to create a 6-membered ring. So this is what it's going to look like. I'm going to have a 6-membered ring right here, and I'm going to number the carbon so I don't lose track of things. This is going to be 1, 2, 3, 4, 5, and 6. Okay, so 1, 6, 2, 3, 4, and 5. On 5, it appears that I have a methyl, so there it is. On 4, it appears that I have a ketone, so there it is. And on carbon 1, I have a methyl. Next to that, I have a ketone right there. And on 6, I'm going to have an O-. Well, that is looking good. Now, it's going to abstract a hydrogen from water, giving the aldol addition product, and then finally it's going to undergo dehydration. Okay, so we have this. And then the way it undergoes dehydration is that hydrogen is going to be eliminated from this position with the base, but OH doesn't leave along with it at the same time in an E2 fashion. This doesn't happen. What happens is in fact an E1CB reaction, which means that OH abstracts this hydrogen in the rate determining step of the reaction, and then the leaving group gets to leave in a fast step. The reason why that matters is because if OH is not leaving in the rate determining step of the reaction, the fact that it's a poor leaving group is no longer going to matter, and that's the reason why this reaction follows an E1CB mechanism, not an E2 mechanism, because OH is a poor leaving group, and you don't want to have that poor leaving group leave in the rate determining step of the reaction. So this is the product, and in fact, this is what we expected to get, and that's the mechanism for this reaction.
Well, if you like this video, don't forget to like, share, and subscribe, and also check out my website, yourokmtutor.com. See you next time.